Dark Boost uses video processing to digitally brighten darker areas in scenes with bright foreground surfaces or glare, but it does not overexpose or degrade the contrast of uniform scenes. This can be helpful in a number of different situations, but first let's take a look at a graph that helps show what is happening behind the scenes. All cameras apply gamma correction, where the levels of darker pixels in the image are boosted digitally. This makes the images look normal to our eyes. Otherwise, the image would be very dark. Dark Boost assesses the brightness content of scenes and intelligently adjusts the gamma correction level to further increase brightness in dark areas. If you look at the curves in the graph that represent normal processing and Dark Boost processing, we see little effect in brighter areas. Look to the right side of the graph and note how the lines are very close to each other. But a dramatic effect occurs in the dark areas. See the left side of the graph. Now let's take a look at some examples to show what this looks like in an actual scene. Notice in the top image, a low contrast scene, the image is not changing with nominal brightness and Dark Boost settings of 0 and 90. In this case, Dark Boost has little effect on the scene. Remember the lines on the right side of the graph on the previous slide. The high contrast scene in the lower image set shows a constant brightness level, but with Dark Boost set at 0 in the left image and 90 in the right image, we see a very apparent difference. This difference can help give an inspector the information needed to make good inspection decisions. If you own a Mentor Visual IQ, experiment with the brightness and Dark Boost sliders and note how they impact image quality in different application scenes. Turning up brightness can increase blooming. Dark Boost increases the likelihood of spotting an indication. Let's look. In the left image examples, brightness is maximized and blooming occurs. In the right examples, brightness is nominal and Dark Boost is maximized, providing a much better outcome. Notice how more of the heat-affected zone and weld toe is apparent in the right weld image in the top left. Also, because in stereo measurement, pixel matching is so important, Dark Boost can be a way to get a more measurable image. Let's look at another example on the next slide. Let's take a look at the difference using the right image when applying Dark Boost. First, note the panels in the combustor liner in the lower right. Take a look at how much brighter and more clear that picture is. And second, if we look at the nozzle guide vane in the upper left, take a look at the right-hand side. You really can see clearly in there and make out detail that's just very hard to make out in the left-hand image. Let's finish up Dark Boost by examining some key points. First, Dark Boost does not affect low contrast scenes. Use it when looking at welds or compressor blades or even additive parts. It can be useful when using real 3D stereo measurement on shiny surfaces, and it's also helpful when using wide area field of view tips where illumination is sometimes not uniform.